Okay, so today we are on lesson 7.6, and we're going to be working with solving systems of linear equations. But today, it's the inequalities that we're working with. And if you remember, inequalities was the last chapter that kind of gave a few people a few hiccups on this, a little difficult. Today's lesson actually should not be that bad. It's fairly straightforward and simple. So, we're going to get into it. First thing is we have to graph on this warm-up. This is going to be very important to today's lesson, but we have to graph the inequality. So what I'm going to do is, when I look at the inequality, we still want to set it up just like any other equation. We want to set it up in slope-intercept form, so we can identify the slope and the y-intercept. If I look at number 1, it says y is greater than or equal to negative 1/2 x minus 2. Okay, for a second, just pretend that it's not a greater than sign, that it's just an equal sign. So we could go ahead and graph this. Our y-intercept is negative 2 with a slope of negative 1/2. So you guys done very well with graphing. Alright, so first thing I do is I put my point, my y-intercept, and we want to go put it at negative 2. And then we use our slope, negative 1 over 2, negative 1 over 2. I'm going to go up 1, left 2. And I'm about to make my line, but I'm going to stop because now I'm going to think of my inequality. Do I want to make a solid line or a dashed line with this inequality?
Solid.
Why a solid?
Because it's less than or equal to.
Very good. Remember, if it was just less than, or if it was greater than, that's on dashed lines. But if it's less than or equal to, or greater than or equal to, then we use a solid line. So I'm almost done. I have the line made. But remember, since it's inequality, these are the ones that we are going to shade. Because y can be larger on this one, greater than. Because it is greater than, we shaded everything above our line. So this is how we graph our inequality. If it's greater than, we shade above. If it's less than, we shade below. If you can do this part, today's assignment's going to be fairly easy for you. Okay? We're going to look at number 2. Can I graph it as it is? No. So obviously, we're going to go ahead and take it and we're going to solve for it. So I'm going to put 5x minus 3y is less than 15. And we want to solve for y. So I'm going to subtract my 5x from both sides. Negative 3y is less than negative 5x plus 15. Divide by negative 3. Y. This is going to be a positive 5/3 x minus 5. What sign will I use? What's my inequality sign? Y greater than. Perfect. Remember, if you divide by a negative number, your sign must flip. So now we take this and I'm able to say my slope is 5/3 and my y-intercept is negative 5. Negative 5, 5/3. So 5, 3. And I'm going to go ahead and make my line. Dotted or solid? Dot. Okay. And it is greater than. So So I'm going to go up on the top of it. I'm doing this backwards. No. All right. Any questions on how we did this? We feel good about this. If you feel good about this, this is really where I want you to make sure you understand, because today's is all about this. Any questions about what we did or why? All right. So today's learning goal is I will solve systems of linear inequalities. If we look at the information, it says a system of linear inequalities in two variables, or simply a system of inequalities, consists of two or more linear inequalities in the same variable. So our examples show. So mainly they said x minus y is greater than 7, 2x plus y is less than 8. So those are together, just like we've been doing with systems of linear equations. A solution of a system of linear inequalities is an ordered pair that a solution of each inequality in the system. For example, 6, negative 5 is a solution to the system above. So like we did before, if we found like where they cross or stuff, then that's a solution. That could be an answer. However, since it's an inequality, the graph of system of linear inequalities is the graph of all the solutions. Here's the difference. Mainly what we've been doing, we found when we graphed two lines, we found one point, and we said that point was the solution. Well, if we have an inequality and we say greater than, we're going to find out that it could be that point or more. There's like infinite amount of solutions, because we can either go higher numbers or lower numbers. So here's how we're going to do it, and it's fairly simple. Step 1, you're going to graph inequality as we've learned in chapter 6.7, just like you did warm up 1 and 2. You're going to find the intersection of the half planes, and the graph of the system is in this intersection. Mainly, we're going to shade in one of the inequalities, you're going to shade in the other inequality, and where the two overlap, that's your answer. We're not going to write down an answer because it's not one set point. This is one of those that you are going to have to visually look at your graph to see your answer. Okay? So, we'll do an easy one to start off with. X is greater than negative 5. Okay, what kind of line are we going to have? Maddie?
Dotted.
Okay, it's going to be a dotted line. What else?
Greater
Greater than? Something else special about the line. It's going to be a vertical line. This is just like if we would have said x equals negative 5. That's our undefined line, vertical line. So I'm going to go to negative 5, and it's pretty much any of these points, correct? And so we're going to go ahead, and I'm going to use, like Maddie said, a dotted line. But x is greater than negative 5. So do I shade on the left side or the right side? Right side. Good. So I'm going to use my yellow highlighter, because this might help you see this. And I'm going to shade everything to the right. Technically, I could just use a pen and do a bunch of marks faster. I like what this is going to look like. Okay. My second line that I'm going to graph is x is less than 2. Once again, we're going to have a vertical line here at 2. Dotted line. But because it's less than, we shade left. So I'm going to use my blue. Anything from here on. I'm not going to use the highlighter every time. Alright, now when we look at our graph, I'm going to do a little more blue just so we make a point. Alright. Now, to make a point, that's why I did that. To identify our solution, one, the solution for x is greater than 5 is anything that was yellow from here over. Any of these coordinate points. -1, 1 would have worked for that one. Or 5, 1 would have worked for it. For x is less than 2, it's anything left of that line. So anything blue over here, or anything found inside of here, like -1, -5. But what we are asking to find today is a solution for both of them. So when we graph this, the solution for both of them is going to be anything that turned green on my picture. If I ask you to find 3 possible solutions for this system of inequalities, you could choose any point inside of here that was green. I could say this point that was -1, 3. I could choose this point, 0, -4. I could have chose this point that was -4, -5. Anything inside there will make both equations true. Any questions on that? It's fairly simple. We don't write out an answer. It's going to be we're looking at our graph. Okay? So when we have the system of inequalities that's like this, it's fairly easy. All we are going to do is exactly like our warm-up. Y is greater than -x minus 2. I'm going to identify my slope and y-intercept. For this one, my y-intercept is what? -2. My slope is -1 over 1. So I say -2 and then -1 over 1. Okay, so that's going to be my diagonal line. I like to put more points. It's easier for me to draw. And am I going to have a dotted or solid line? Dotted. All right. And y has to be, we're going to be greater than. So I'm going to shade up on the top half. So here's how I'm just going to use anything there. For our second equation, it's already in slope-intercept form. My y-intercept was 6. Bless you. My slope is 3 over 1. So I go to 6. And 3 over 1, well, I'm going to go off the graph, so I'm going to do the opposite, -3 over -1. 1, 2, 3, 1. 1, 2, 3, 1. All right. And this line will be solid because it's less than or greater than. And I'm going to shade anything on the left side since it's less than. Now when I look for my solution, it's where did the two lines intersect? I'm going to highlight just to show this. My answer is going to be anything inside like this area. And of course, not just this small triangle, it continues on forever because the lines continue on, so the triangle will still get bigger and bigger. But my solution is going to be inside there because that's where both lines intersected, or where both regions, I shouldn't say lines, but both regions of both solutions. Any confusion on why this solution is in here? Pretty straightforward, right? This is the trickiest part of today's assignment, to be honest. Go ahead, I'm going to stop, and I'm going to pause this. I'll start doing mine up here. But go ahead and try and do this one by yourself without me. just to make sure that you're doing it correct. So if you need to work with the partner, I'm okay with that. Check with them, but what we need to do is graph each inequality and then see if you identify the solution for the system of inequalities. All right, so looking at this once again, your graph should have looked like this. Make sure your line going here, which was my y is less than x minus 4, is a dotted line, because it's only less than, and you shaded the bottom half. So that would have been my yellow, that was everything over here. For y is greater than or equal to negative x plus 3, that was anything in the blue that went up. I colored on the right side. My solution is this in the green. It's where the two planes intersect. Okay. Tatum was asking me a question about, do we have to write something down for our answer? No. Remember, on today's, we're not writing like an answer like 6-5 or 17-3. Our answer is just going to be a visual. You will look at your graph and have to see where your answer could be. Okay? Now, before I get to this one, when's the time you can think that you might have no solution? I don't think we do an example. I don't remember if we do or not. Connor? Yeah, if the lines are parallel and they go the opposite directions, what we're shading. I'm just going to do it on this graph real fast. If for some reason I had this line and I shaded this direction, and I had a parallel line, but we shaded this one. If we had that, where we have parallel lines and we're shading in opposite directions, we do not have an answer. Okay? We have this buffer zone, but there isn't an answer that's going to satisfy both.
And the same thing goes for everything in any, if it's the same line.
If it's the same line, it depends. If it's the same line, if it shares the exact same line and we're shading the same direction, you'd have infinite many. But, so like if we had this line and my other line was the exact same one, and we shaded both in the same direction, you'd have infinite many. It'd be whatever was shaded. But it is possible that I have the exact same slope and y-intercept, but we use a different inequality. Then they would be going the opposite direction.
And then there would be no solution.
Maybe. You would have to think, if it says like less than, greater than, you'd have no solution. But if it would be equal to, it could be any point on the line. Because it could sit on there. So that's why inequalities are so much fun. All right. Let's look at this one. And I might have us. Oh, then I want to give you that thing. Okay. So, almost done. This isn't going to take long. Let's look at this one. And then I'm going to give you a foldable that you can fill out and keep in your notebook for reference guide. And I'll let you work on your homework. So, do you think we're going to do anything different on this one?
No.
It's just 3 inequalities. So, where's my solution going to have to be?
Between all three.
Has to involve all 3. What if it doesn't involve all 3? Alright. So, I'll pause. You work on it. Alright. So, see, yours looks nice. Okay. See, this is the part where I'm not going to like this because it's not nice and neat. Colored pencils would be fantastic to use if you did your homework or something. Use light colors and shade. But let's make sure we just understand what we're doing here. So, we shaded everything. I used pen, if you guys saw mine earlier. I used just a scribble, and it just looked like a giant mess. Like I let Jude just go to town with a smartboard. He's my 4-year-old. So when we do this, we're going to have to be a little careful. You probably want to use light colors and shade to cover, or even if you use patterns, where maybe I just do lines vertical, and then I do lines horizontal, and then I shade on the other. But mine's not even showing up to 2 different colors because the green overpowered my blue. But do we have a solution?
Yes.
My solution is going to be inside this area. That line goes on forever. This line goes on forever. So we are inside this area. which look how pretty it is. So, alright, here's what I'm going to give you guys for the rest. This is mainly what you're doing today. I'm going to give you the foldable because they said to complete the example in the foldable. The foldable is really easy that we're going to put in there. It just is giving you the steps. We want to put this in there so when we review for the test, that here's an easy review. So hold on to this. Make sure you put this in your foldable or your spiral. As soon as I finish handing that out, I will hand out your homework. Your homework for tomorrow is worksheet 7.6.